All right, so get ready because today we're going to be looking at some pretty crazy AI research.
Oh, yeah.
Yeah, it's really interesting stuff. We're talking about whether these large language models,
Uh-huh.
the things that write poems and can summarize articles,
Okay.
if those things can actually like reason
Uh,
and solve brand new problems.
that's a big question, right? Gets to the heart of what we even think intelligence is.
Yeah, exactly. And the research that we're looking at today used this set of visual puzzles
Okay.
called the Abstraction and Reasoning Corpus, or ARC,
ERC, okay.
to test this whole idea. So think like those IQ test questions.
Right, with the shapes and patterns.
Yeah, but like way more complex.
Yeah, ARC is like notoriously difficult, even for humans.
Right,
It's not just like, oh, I see the pattern. It's like understanding the logic behind it.
right.
And then how to apply that logic to like a whole new situation.
So how do you even get a language model to see these visual puzzles?
That's a good question.
Mm-hmm.
But they had to basically translate these visual puzzles into text,
Okay.
like describing the shapes and the colors and where things are positioned
Mm-hmm.
in a way that the LLM could process.
So they just gave the LLM a bunch of these text puzzles and said, figure it out.
Well, they tried that at first. It's called in-context learning,
Okay.
where you give it a few examples and hope it kind of picks up on the pattern.
Yeah.
But for something as hard as ARC, especially with smaller LLMs, it just wasn't really enough.
So then what? Did they have to go build some massive LLM, like break out the supercomputer?
Not necessarily. They found this technique called test time training, or TTT.
TTT.
Yeah, what is that?
That could like really boost performance, even for these smaller models.
So is that like giving the LLM a crash course in logic, like right before the test?
Yeah, that's a good way to put it. Basically, TTT lets the LLM learn during the test itself.
Whoa.
It uses this like mini training set generated from the test input. So it's like it can study the problem and adjust how it's going to approach it.
Yeah, in real time.
That's wild. Okay, so what were like the key ingredients to making this TTT work?
So the research highlighted three main things.
Okay.
First, they found that like priming the LLM was important.
Priming.
So like pre-training it on similar tasks, give it kind of a head start in abstract reasoning.
Right.
But, and here's the weird part,
Okay.
pre-training on tasks that were created by other LLMs actually hurt performance.
Really? So human-designed puzzles were better for teaching it?
That's what they found. It seems like there's something about the way humans structure problems that current LLMs just can't quite replicate.
That's a pretty big thought,
Yeah, maybe it's the specific logic we emphasize.
All right.
Or maybe there's some secret ingredient to human reasoning that we just haven't figured out how to code yet.
Interesting. Okay, so what were the other two ingredients?
The second one was using what they called augmented TTT data.
Okay.
So imagine taking one of these ARC puzzles
Uh-huh.
and you rotate it, flip it, maybe change the colors around.
Okay.
The logic is still the same underneath, but the LLM gets to see the problem from all these different angles.
So it's like giving it a more well-rounded understanding,
Yes.
not just like one rigid way of looking at it.
Right. And the third ingredient was using something called task-specific adapters.
Task-specific adapters, what are those?
Think of them like specialized toolkits for each problem, instead of one giant general-purpose set of tools.
Makes sense.
That's
Okay,
the
so they prepped the LLM, they gave it this augmented data, they gave it the toolkit.
Yep.
How did they actually get it to come up with solutions? Did they just tell it to spit out an answer and hope for the best?
No, not quite. They actually had it generate multiple solution candidates,
Ah.
kind of like brainstorming,
Yeah.
different possibilities.
Uh-huh.
And then they used this voting system
Uh-huh.
to pick the most likely answer.
So they were mimicking how we might try to solve a puzzle.
Yeah, exactly. Try a bunch of different things, see what fits best.
Right.
And, not surprisingly, they did find that the bigger LLMs
Yeah.
generally did better.
Right, makes sense.
Bigger models, more parameters. They can process and learn from more complex stuff.
Right.
But here's the important part.
Okay.
PTT actually helped to close the gap
Oh, interesting.
between those massive models and the smaller ones.
So even a smaller LLM with the help of TTT could potentially solve these crazy complex puzzles.
Yeah, potentially. It makes this kind of cutting-edge research a lot more accessible,
For sure. Especially for people who don't have access to the supercomputers and all that.
Exactly.
Okay, drum roll, please. How did these LLMs do on the ARC challenge? Did they manage to crack the code?
Well, when they combined TTT with another approach called BRRE, which we'll talk about more later,
Okay.
They actually got an average accuracy of 61.9%.
Wait, hold on. 61.9, that's like
That's the same as the average human performance on this data set.
they matched human performance on something that's designed to be super hard.
It's pretty wild, right?
Yeah.
They even beat some previous state-of-the-art results,
Huh.
including some that used symbolic AI, which people thought was like essential for this level of reasoning.
So hold on. Before we get too excited, did any of the LLMs beat the best human performance?
That's a good question. And it shows that we still have a lot to learn about human reasoning. The best human still beats AI on this, getting a crazy 97.8% accuracy.
97.8%. That's almost perfect.
Really puts things in perspective, right?
Yeah.
Even with these amazing advances, there's still something special about how we approach these problems.
So even though LLMs can now match average human performance, there's still this gap between how the best humans and AI solve these puzzles.
There is, and that brings up a huge question.
What's that?
Are LLMs really reasoning the same way we do?
Uh-huh.
Or are they just getting really, really good at pattern recognition?
Yeah, like, are they understanding the logic or just mimicking it really well?
Exactly. And that's what we're going to keep digging into as we look closer at this research.
Okay, I am ready. Let's keep going.
It really makes you think, what is it about human reasoning that's so hard to copy, you know?
Yeah. Is there something like fundamentally different about how our brains work?
Well, that's a question for another deep dive, but for now, let's get back to this research.
You okay?
Remember how we were talking about priming the LLM before the test?
Yeah, like giving it a boot camp in abstract reasoning.
Exactly.
Before it had to do the ARC challenge.
Right. So they actually experimented with a bunch of different pre-training strategies.
Oh, okay.
Like they tried using existing puzzle generators, having another LLM create new puzzles,
Okay.
and even using those geometric transformations, you know?
Like the rotations and flips and color changes.
Yeah, to create variations of existing puzzles.
So it's like they were trying to find the best way to teach it about the underlying principles of abstract reasoning.
Exactly. And the results were pretty interesting.
What'd they find?
The best pre-training strategy ended up being this combo of using existing human design puzzles
Okay.
and then applying those rule-based transformations.
So giving it more diverse examples of the same types of puzzles.
Yeah.
Rather than introducing completely new ones.
Right. You'd think more variety would always be better.
Yeah.
But in this case, it actually backfired.
Huh. That is interesting. It really shows we don't totally understand how these LLMs learn.
Yeah, it's humbling.
What works for us doesn't always work for them.
For sure. Okay, let's talk about model size for a minute.
Okay.
We all know in AI, bigger is often better, right?
Right.
Did that hold true in this research?
That's a great point. And like, I'm curious if TTT can help level the playing field a little bit.
Between those massive models?
Right, and the smaller ones.
You know?
Yeah.
So yeah, bigger LLMs did generally do better on ARC.
Right.
Makes sense.
More parameters, more data.
Yeah. But here's where it gets really interesting.
Okay.
TTT actually helped to close that gap.
Oh.
It let smaller models get to performance levels that were only possible before with those giant resource-heavy models.
So we don't necessarily need those supercomputers to do cutting-edge research in this area.
Right. That's what's so exciting.
PTT could make this kind of advanced AI more accessible, you know,
For sure.
for way more researchers.
And potentially speed up the pace of discovery.
That's huge. Okay, let's shift gears a bit.
Okay.
Talk about how this research stacks up against other approaches.
Okay.
But on the full ARC benchmark?
Right.
Because remember, we've been talking about this subset of 80 puzzles.
Yeah, the development set.
Right.
To really see what TTT could do, they had to compare it against other top systems
Okay.
on the complete ARC public evaluation set.
Right, so like taking it out of the lab and seeing how it does in the real world?
Good analogy. And the results, they were impressive.
What'd they find?
Their TTT method, when they applied it to a large language model called BRRC,
Okay.
got 53% accuracy on the public validation set.
53%.
Yeah.
That's pretty good.
Considering how hard ARC is, that's amazing.
Yeah, and that's on the full benchmark, right?
The full thing, not just the development set. And this beat a lot of previous fully neural approaches.
So TTT was clearly making a big difference. Did they do any other combos?
Yeah. They found that when they combined their TTT method with BRC's program synthesis component, they got an even better result. 61.9% accuracy.
61.9. Wait, wasn't that the average human performance?
That's right.
Whoa. They matched human performance on the full ARC benchmark.
by combining TTT and program synthesis.
That is incredible.
It is. Maybe TTT is like a key ingredient to getting even better performance in the future.
It really shows the power of combining different approaches, too.
For sure. Using the strengths of both
Yeah.
TTT and program synthesis to solve these hard problems.
It's like building a dream team of AI techniques.
Yeah.
Each one brings something unique to the table. But we got to remember,
Yeah.
the best human performance on ARC is still much higher, like 97.8%.
Right. Still a big gap between AI and the top humans.
Yeah.
Reminds us there's a lot we still don't get about human reasoning.
Okay, so back to the big question.
Yeah.
Are LLMs really reasoning, or are they just getting really good at pattern recognition?
Right.
This research gives us some clues, right?
It does. Remember we talked about those two main approaches to solving ARC?
Yeah, program synthesis and the fully neural networks.
Right. Previous research had shown that those two approaches were actually pretty complementary.
Okay,
Like they were good at different types of puzzles.
like two specialists.
Yeah. Each with their own area of expertise.
Makes sense.
But what this new research showed
Yeah.
is that TTT actually boosts the fully neural model a lot.
Oh, interesting.
It can now solve way more puzzles that before only the program synthesis model could handle.
So TTT isn't just making LLMs better.
Uh-huh.
It's blurring the lines between these two approaches.
Exactly. It seems like TTT might help those fully neural models learn more systematic reasoning patterns, like capturing some of what program synthesis models do so explicitly.
So TTT could be a step towards bridging the gap between these two types of AI.
Maybe it's not either, but more of a spectrum.
Yeah. Makes you wonder what else LLMs could do with the help of TTT.
What other impossible things might become possible?
What other mysteries of human intelligence could we unlock?
It's what keeps us researchers up at night.
Yeah, I bet. It really is kind of mind-blowing to think about.
Yeah,
Especially as these models keep getting more powerful.
absolutely. And like any powerful technology,
Mm,
I think it's important to be careful,
right.
Consider the ethics of it all.
Yeah, for sure. Speaking of being careful, the researchers did mention some limitations to their study, right?
Yeah.
Like the computational demands of TTT.
Yeah,
And they didn't do a full error analysis.
right. Those are big ones.
Anything else we should be thinking about?
Oh, they also mentioned this thing about data leakage during pre-training.
Data leakage. What's that?
So basically, there's a chance that some of these LLMs might already seen some of the ARC puzzles
Oh.
during like their initial training phase.
So like accidentally giving the student the answers to the test beforehand?
Exactly. It makes it hard to tell if they're really understanding or just relying on what they already knew.
Right. It's not a fair test then.
Yeah, it's a good point and something future research should probably try to address.
Maybe using totally new puzzles that haven't been out there in the world.
Right. Level the playing field.
Makes sense. What about that error analysis?
Yeah.
Why is it so important to understand not just that TTT works, but how it works?
Oh, it would be so valuable to see like how the LLM is making decisions during TTT.
Yeah.
You could figure out its strengths and weaknesses,
Right.
see what kinds of errors it's catching and fixing.
It'd be like peeking inside its mind,
Right.
seeing how it's changing its strategies as it goes.
It'd be amazing.
Okay, so zooming out a bit. If TTT can do this much for something as complex as abstract reasoning,
Yeah.
what else could it do? What other doors could this open?
It's pretty exciting to think about. Like, imagine using TTT in fields like medicine, engineering, even art.
Oh, wow.
Could LLMs design new drugs, create new materials, compose music?
It's hard to even imagine all the possibilities.
It really is.
I think that's what makes this research so fascinating, right?
Yeah.
It's not just about solving puzzles, it's about understanding what AI can really do.
And how it could change the world.
Right. It shows that we're still just scratching the surface of what AI is capable of.
Totally. Who knows what amazing breakthroughs are coming next?
As we finish up this deep dive,
Yeah.
I want to leave you with a question to think about.
Okay.
If LLMs can be taught to reason,
Uh-huh.
what other impossible things might they be able to do?
With a little help from test time training.
Right. It's exciting and a little scary.
For
Yeah.
sure. And if you want to dig into the nitty-gritty details of this research,
Yeah.
check out the show notes. We'll have a link to the original paper.
Great idea. Until next time, keep exploring, keep asking questions.
Keep diving deep.
And remember, the coolest discoveries are often hidden just below the surface, waiting for us to find them.